So we have an equation in a particular form right here. And it has a base e in it right there. And there's a way we can solve this then. So what we want to do is we want to divide both sides by a. So we'd have y over a equals e to the power of kt. So a lot of times we get these types of equations for exponential growth and decay, population formulas sometimes, or radioactive decay formulas sometimes. Okay, so that's what you do. You kind of get the e part to by itself. Then what we're going to do is we're going to apply the natural log to both sides. Okay, so you could have some questions here like, oh, am I going to split up the division into two separate logarithms? I wouldn't. I'd probably just leave it y over a. A lot of times we put these in a calculator to get a decimal approximation, so I would just leave it that way for now. But here's the exciting thing. The left-hand side, it's just what it is. But on the right-hand side, that comes back to that property when we had, if you have a log base b of b to the x, that just equals x. So that was one of our inverse properties, and it's really exciting because now on the right-hand side, we can just use the exponent kt. If I'm trying to solve for t, I divide both sides by k, and I'm done. Okay? So that's just the method. I'll show you a real example here that we're going to go through. So I look at my equation. I've got 100 equals 20 e to the 2t. So I'm going to divide both sides by 20, which is nice. It goes in evenly. Now I'm going to take the natural log of both sides. I want to do the natural log because of that base e. If I tried using a common log, see, it wouldn't work because then I wouldn't have the bases matching up. It wouldn't be the inverse property. But because it's an e and I'm using natural log, it's going to work out nice. Okay, so I get the natural log of 5, oh, I should put parentheses, equals 2t. And then we're almost done. All we have to do is solve for t, so divide both sides by 2. Now remember, this gives us t is equal to the natural log of 5 divided by 2. That's just a number. We can put this in a calculator, get a decimal approximation. If they want an approximation, they should tell you. Otherwise, we assume that we want an exact answer. Okay?